6 days. One password. That's okay. All right, so I have a disadvantage not being able to see the slides. That's okay. So Andy and I didn't start out working together, but we had kind of a mid-air collision a few days ago where we found that a lot of what he was working on and a lot of what I was working on was related. Well, might as well start telling the story. We kind of combined my work with mesh networks with Andy's work with putting a Kubernetes cluster on a stack of pies. So if you want to hit the next slide, please. Or is there a remote? No. Okay. So, I'm always preparing for the digital apocalypse, and so I'm pretty interested in alternative networks in general. And I like peer-to-peer networks, but before the Raspberry Pi, I was missing something really important, which was peers. So now I can buy friends for $35 a piece, and I did. I got a bunch of them. And, basically on a dare and a half a bottle of whiskey, decided to start throwing all this stuff together and dug around for something that would allow a friend of mine to put cameras in his conversion van, and ended up scaling out something that would really probably work better over several city blocks. I discovered a project called Batman ADV, which is a kernel level mesh packet switching for Linux. And I knew of the project. I didn't know how long it had been around. Apparently it's been native to the kernel since 2.6, so like 15 years or so. And so readily available on the Pi. And I started out with, I just made all my friends give me their Pis. And started just tying these together. Now, a mesh network means that if you think about how your Wi-Fi works at home, you have an access point or maybe a couple, and everything's got to talk through that access point. That's fine, but when you've walked out to the far end of the garden, your shit doesn't work anymore. So instead, what we're doing is no access point at all. All of the Pis are coming up and detecting one another and routing their traffic through each other. And it actually works remarkably well. Now, this operates at layer 2 in the OSI layer, so for those of you who can remember, at least remember up to level 2. And that means that this is happening before even IP kicks in. So you actually have decent routing at a hardware level before you assign IP4 or IP6 addresses. So that's the first part. In addition to that, I found that, I needed to do something with this network. The funny thing about infrastructure people is you build stuff and then you don't have anything to run on it. Today is no different, but I did find that associated with this project is another data structure called Alfred. You can see where these guys are going with their theme. Alfred allows you to distribute data around the network relatively efficiently. And with it, it allows you to share visualization data, weather data, whatever you want, and just pump data into the network. I built on top of that, and we'll see it sort of work today, a server in Python, which is what I tend to do most of my work anyways, that monitors this data server and provides REST endpoints outwards so that we have kind of an easy interface to the mesh and to the data on it. Next slide, please.
Did you want to demo the mesh?
No, just go ahead and say what you're going to say. We'll
okay. So I started out building a Kubernetes cluster on Pi. Everybody asked me why. I said I don't know because I can. Because Kubernetes. So I started out with that. I found a Pi image that allows you to use Cloud Init to bootstrap the Pis. So I can image all these SD cards. They come up, install all the packages, and actually bootstrap the Kubernetes cluster, which is kind of cool. It's all connected to a switch. It's sitting on my desk right now for network reasons. And then I started talking to Adam, and I was like, wait, only the master really needs to be connected to Ethernet. I could run all the rest of the nodes on this mesh. So I spent the rest of my time spinning up a mesh network and running a DHCP server on the master node so that all of the slave nodes could get IP addresses over the mesh. And I'll show that in a minute. But basically, you plug in these Pis, format the SD cards from the Python script that I wrote, and they come up as a Kubernetes cluster and can communicate over just the mesh network. So I could actually unplug all 4 of the nodes and just leave the master node plugged in as a gateway to the internet. now we'll just start doing demos.
Okay, and the second you stopped talking, I dropped off of the network. Oh, it's that ReadyTalk Wi-Fi that's so new and good now.
Oh, hey, we can see our screen. Can you see our screen?
Okay. Hell, how do you make him see? Oh, wah wah. I lost everything.
Which network are you on?
It's the demo gods. Can you see me fail? Oh, that was wholly uncalled for. Okay. Is that a thing we can do without ruining everything? Sometimes you just gotta unplug it. Oh.
We could see it here.
Boy, if
We
you
could
could
just turn
see
this
what I
around.
was seeing right now. You bang on top of it. Yeah, where's the camera? No signal. Okay.
Does this camera work?
Okay, let's just
Or
do our
that one?
best.
There's a camera up there.
Oh, hey, there we go. Boy, I'm glad there's nothing weird on my screen. Okay, so, anyways, so in pure Stack Overflow fashion, when Andy decided he was going to join my mesh, he copied my configuration wholly and then put it on all of his nodes. So what we're seeing here is every node that's on the network. There's 2 at my desk, what, half a dozen on yours. There's 2 in this room over here, and then I ran out of USB plugs. And so as these come up, they start kind of casting about to try to find peers that operate on the same cell and on the same ESSID. There's no security at this level. It's too low. So you generally expected to build your security on top of that. Guess what else I didn't get to finish by Pi Day. So if you want to join my mesh, you can. But what you're seeing here, there's not this many nodes, but every row you see on screen that has a star next to it is an independent node running, or Pi running on our mesh. What the rest of the lines are is, being a mesh, it can see certain machines directly, and it can see other machines through other machines, right? So this allows us to smear out over blocks and blocks if we wanted to. But because we're all in one building and the antennas on these Pis are actually pretty okay, we're able to see all the other nodes as well. So what you're kind of seeing is a topography here. I did build that web server, like I said, to share data across all of these machines. I also tried to build a command and control server into it to elevate the blinky light to an infrastructure problem. But, well, that's running on my desk, and you can see that later if you want to come by. In the meantime, we're also collecting visualization data, and among the things I started and didn't finish was a force-directed graph. But what we're seeing here is the network from the points of view of every node. So some nodes can see some other nodes, some nodes can see all nodes. And so every one of these blocks adjacent here is basically the network from the point of view of one computer. So as you can see here, here's one that can only see 5 of its peers. Here's one that can only see 3. This one seems to be positioned pretty well. So it just kind of takes care of all that for you. If you do get into the Batman ADV protocol, there's a whole lot of smart in there. This is technology that's now being used across larger European cities and Southern Hemisphere villages to take a single leased line and some commodity hardware, usually not on a Pi, but on something embedded like OpenWRT, to take one leased line and basically spread Wi-Fi across their entire village. So it's a kind of remarkably capable software for being just kind of quietly hiding in your kernel.
So like Adam said, I literally just copied his configs, joined his network. I didn't even realize it. I copied his configs, showed up in the office, fired up all my Pis, and all of a sudden he's like, hey, you're on my network. because it's really that easy to do. I don't know how much of this you can see. Make it a little bigger. So in the top left, I'm just running a kubectl get nodes. You can see all 5 of my nodes, 1 master, 4 workers. And then just below that, I've deployed an Nginx, just a basic Nginx container with a single replica. What we can see is if I get on the master node, we can see that the master node is handing out IP addresses, and if we look at ifconfig bat0, we'll see that all of the IP addresses that are on the nodes are actually running over the bat0 interface, which is the mesh network. I'm connected to the master via Ethernet, but everything else runs over the mesh. Let's see, what else did I want to show? We can see that it's connected to the mesh by running that. That's all the nodes that I'm connected to. And then we can hit the Nginx status page on the cluster. Wow, that's tiny. And if we do this a few times, right now there's only 1 pod running, so that number just keeps incrementing. But if I scale that up to 5 pods, you'll see the pod list on the left increase, hopefully. So one of the things I learned is that running images on the Pi is a pain because they have to be compiled for ARM. They have to be built for ARM. Luckily, the Nginx container is by default, but most containers are not. So, and if we keep running this, you'll see the numbers jump around as we hop around between different nodes in the cluster. So that's Kubernetes on Pi.
Oh, we both learned a whole hell of a lot of stuff here. I think this you want to go first. You're on the left.
Sure. Kubernetes networking is fun and exciting. Cloud init is awesome, and finding a Pi image that automatically implements it is great. You just specify a YAML file, and you can configure users, files, and run arbitrary commands on boot. Python is great at handling YAML to generate those configs. kubeadm is awesome if you've never set up a cluster that way. That's what bootstraps the cluster on the Pis. And I already said that one. And don't try to compile a kernel on the Pi. It just takes too long.
I really got into this mesh thing quite a bit, and this project's going to live long past Pi 8 for me, because I think this is going to be a bit of my focus for a while. So the Batman project is still active. A bunch of freaky nerds out of Germany are working on it, and they're super responsive. So in a couple of cases where I got stuck, jumped on IRC to help me out. It was really great. Alfred itself is a pretty good server for distributing data, bad for issuing commands, as I can prove, but super great for pulling data from a lot of different places. It uses some wild binary formats because this is pretty low level and you want it to be efficient. And I learned a lot about how to start analyzing those formats and breaking them out. We have some links I'll share, but I also came across this really fantastic Python library called Construct that allows you to write Python objects that really just follow along with C structs and parse them out for you real clean. So that was a big win for me. I stubbornly insisted on sticking with IP6 and everything I know about IP6 I've learned in the last 6 weeks. Boy, there's a lot more depth there than an address space, so I hope to share more on that soon. I did figure out my Unix domain sockets problem. I was going about it all wrong. We just don't do that a lot anymore, and honestly, it's fast and fairly secure, so I'll use that again. Had I actually shown everything I tried to do this time, you would also see that I learned a bit about IP math because I wanted a lot of self-discovery and broadcasting, and I'm just not good at regular math. So calculating IP addresses has actually been a challenge. So that was an eye-opener, especially this late in my career, to start filling those gaps. One more slide. Sorry if we're running over. We'll share this, or this will be shared with everybody. Here's the links that Andy and I kind of relied on to get this project done. The Open Mesh project for my part of it. The next two are Andy's.
Just a blog article about how to use Cloud Init with the Raspbian image, kubeadm documentation, your GitHub repo.
Oh, so the Alfred client, the fourth link down, actually has the code that I wrote in Python that didn't really feature prominently here today, but had a lot to do with getting the project done, and the instructions on how to set one of these meshes up from the ground up. So if you want to play with it, Andy was able to do it in an afternoon with few complaints and only a couple PRs to correct it. And then construct and your repo.
Yeah, that just generates cluster configs. So.
Sweet, thanks.
That's it. Thanks.